Pre, alam mo yung topology of the cup of the donut?
Pa-invent tungkol sa cup na pwede ma-mold sa donut.
Oo, pre, yun.
Pero possible ba yun?
Uy, pre, paano mo nagawa yun?
Hey there everyone! We're going to explore some cool stuff about shapes and how they can change. Today, we're going to check out two things you probably see every day: cups and donuts. We will tackle about the topology of the cup and donut.
Topology is a branch of mathematics that focuses on understanding how shapes can be transformed through stretching, bending, and twisting without tearing or gluing. It emphasizes the overall structure of shapes rather than specific measurements or angles, providing insights into their fundamental properties and relationships.
Now, we're going to apply it with a cup and a piece of donut.
In topology, the sense of the cup means it can be transformed into a sphere without tearing, illustrating homeomorphism. This concept states that shapes are considered the same if they can be continuously deformed into each other. Thus, despite their different appearances, the cup and sphere are homeomorphic and share the same topological properties.
Homeomorphism is a fundamental idea in topology, allowing mathematicians to classify and prepare shapes based on their intrinsic properties rather than their geometric details. Homeomorphic means two shapes are equivalent if they can be stretched, twisted, and bent into each other without tearing or gluing. It's like saying they're the same on the inside, even if they look different on the outside. This concept helps mathematicians compare shapes based on their fundamental properties rather than their exact appearance.
In topology, the donut refers to a torus-shaped object, characterized by its circular cross-section and a hole in the center. It serves as a fundamental example in illustrating concepts such as homeomorphism, where the donut is topologically equivalent to a sphere. Despite its distinct appearance, the donut shares the same essential topological properties as a sphere, highlighting the underlying unity among seemingly different shapes.
A torus is a three-dimensional geometric shape that resembles a donut or a tire inner tube. It is characterized by a circular cross-section and a hole in the center, similar to the shape of a donut. In topology, the torus is often represented as a surface with a single hole, making it a fundamental example for illustrating concepts such as homeomorphism and the classification of surfaces. The torus plays a significant role in various fields of mathematics and physics, including topology, geometry, and differential equations.
In the metaphor, the mug and the donut are one and the same. If they were made out of rubber, one could be twisted and stretched into the shape of the other without changing its essence. The two are considered topologically equivalent as each has a hole, the ear of the mug and the center of the donut.
The relationship between topology and copy and donuts lies in their ability to illustrate fundamental concepts in the field. The classic example involves considering a coffee cup and a donut. Despite their apparent differences, both can be seen as topologically equivalent to a sphere. This means that they can be continuously deformed into a sphere without tearing or gluing. This simple analogy helps to illustrate abstract concepts like homeomorphism in the classification of surfaces. It also showcases how seemingly different objects can share fundamental properties when viewed from a topological perspective. So while enjoying your morning coffee and donut, you're also delving into the fascinating world of topology.
Looking at how coffee cups and donuts relate to topology is like getting a sneak peek into the fascinating world of abstract math. Even though cups and donuts seem totally different, they're kind of like shaped bodies. They can both transform into a sphere without any fuss. This helps us understand cool math stuff like homeomorphism and how shapes are grouped together. It's a reminder that even in the everyday things we enjoy, there's a whole world of hidden connections waiting to be discovered through math.
Topology.